This is Mr. Mack from Wheaton Academy, and I plan on instructing on organic chemistry. Beginning on page 4 of the notes, we'll be looking at structural formulas and isomers. So some of you have these notes already, so I'm going to go fairly quickly. N-pentane is the straight chain, and even though it doesn't look straight, because each carbon is connected one to the other, we can call it a straight chain. There are a total of 5 carbons and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. A structural isomer is going to be a rearrangement of the carbons and as a result the hydrogens as well. So my first isomer, I'm going to draw the straight chain up to 4, and then having removed the carbon from the end, put that in the middle. You will note 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I still have 5 carbons and 12 hydrogens. So the structural isomer, simply the rearrangement of the molecule, changes its physical and chemical properties. To name this, we look for the longest straight chain, which happens to be 4 carbons long, and that is called butane. Now, there is an attachment of a single carbon, and that makes it a meth with a YL ending, methylbutane. Now we want to specify which carbon that attachment is on. If I count from the left, 1, 2, 3, 4, the attachment would look like 3-methylbutane. So the rule is that we always need to count from the side that gives us the smallest number. So counting from the right would make it a 2-methylbutane. 2 is smaller than 3, so the proper name for this molecule is 2-methylbutane. So removing another carbon from the end and putting it on the middle carbon leaves us with the longest chain being a propane. And there are 2 single methyl attachments. So we have methyl, we have to put it in di, and we have to specify the number. Anytime you have the word di, you're also going to have 2 numbers. So that's going to be 2, 2 dimethylpropane. Of course, there's still 5 carbons, 12 hydrogens, and each of these structural isomers behave differently due to its structure. And they are called structural isomer, and later on we'll learn about geometric, and geometric requires a double bond. And since we're only working with single bonds, this is a structural. All isomers have the same formula but differ in chemical and physical properties. So they may boil at a different temperature, they will react differently, and we can distinguish them and separate them according to those properties. What I'd like you to do right now is take a moment and draw at least 3 structural isomers of N-heptane. 7 carbons total. An isomer has a total number of carbons the same for all structures. So you're going to draw at least 3 structural isomers of N-heptane. Go ahead and pause the video and take a couple of minutes and do that. Okay, welcome back. And I'm going to draw a few isomers, and then I'm going to go back and systematically name several of them. My goal is to show you what an isomer is and to show you how to name them. So our first is going to have 6 carbons, 2, 4, 6, and then I'm going to add 1 there. The next one, I'll just choose to do 5, and I'll add 2 more right there. I'll do a third one, and let's see, I'll spread those carbons out. And so let me name these right now. This is the longest chain, and that chain is 1, 2, 3, 4, 5, 6 carbons, makes that a hexane. And if I number them, that's going to be 2-methylhexane. Going to the right, I now have 1, 2, 3, 4, 5. That makes that a pentane. So I'm going to box out my longest chain of carbons, and counting from the, well, may as well start from the right. I'm going to have 2,2-dimethylpentane. Going to the next one, and let me make that C a little bit better. All right, so boxing my longest chain, and that is 5 carbons, a pentane, all the same. And now counting from the right, 1, 2, 3, 4, 5. That gives me 2,3-dimethylpentane. So let me show you a variety of isomers of heptane. So we just did, I believe, 2-methyl. If I move that to the next one, that makes it a 3-methyl. If I move it to the next one, it is not 4-methyl. That's counting from the right-hand side, still 3-methyl. So there will never be any such thing as 4-methyl. Now, some students try and do a 1-methylhexane, but that's actually N-heptane, so that will not work. Okay, let's go to the pentanes, and I can have, as you just saw, both of the attachments on the first carbon, or I can do the second and third. I can also do the second and fourth, and well, that's it for spreading those out. So if I go to 2 on that middle carbon, oops, I forgot to put the bond in, that would give me 3,3-dimethyl. And I'm just going to write this one in as 2-methylhexane. It is possible to have a trimethylbutane. Still, we're talking about isomers of heptane. So 1, 2, and 3. I am not allowed to put another carbon there because carbon will not accept more than 4 bonds. So it has to go on the next one. So this is going to be 2, 2, 3 trimethylbutane. So first carbon, second, third, and fourth carbon. And that's going to be the only trimethylbutane that we would have. Now it is possible to have an ethyl pentane. An ethyl pentane gives me a 2-carbon chain off of that center carbon, which regardless of the side you start on, is always going to be a 3-ethyl pentane. It's important to note the difference between the 3-ethyl and the 3,3-dimethyl. This is a 2-carbon attachment. This name does not fit that molecule. It's got to be 3,3-dimethylpentane to describe that one. Okay, let's go back to our notes and we'll go through a little bit more detail in regard to naming alkanes. When you have a branch, you will name the alkyl branches the same prefixes we use with alkanes and the suffix YL. And the first thing we need to do is we have to choose the longest chain. So looking at this, I'm going to box the longest chain that I have. Then I'm going to number from the side that gives me the lowest number for the first attachment. So that's going to be 1, 2, 3, 4, 5, 6, 7. The name of this molecule, 3,4 dimethyl, and 7 is a heptane. If I count the total number of carbons, that's 9, so 3,4-dimethylheptane is an isomer of nonane. Okay, my longest chain. Boy, I have made this very complicated. That's what the test will be like, so let's get used to it. All right, here we go. I know you're rejoicing right now. All right, so we have 1, 2, 3, 4, 5, 6, 7. It's a heptane again, but this time I have different attachments. So I'm going to number from the lower right, because that'll give me the lowest number for 2 attachments. And my name will end with heptane. Then I have a dimethyl, so there's 2 methyls, and there is an ethyl. So the ethyl will get named first because E comes before M in methyl. And the methyl is actually going to be dimethyl. And then I'm going to throw my numbers on, 3, 3, and 4. So I have 4-ethyl 3,3-dimethylheptane. Oh, this is fun and easy. Okay, 3-methylhexane, 6 carbons, or if you want, you can go like that. But you're not allowed to go like, whoops, is that, no, I need one more. But boy, that sure would be easy. Okay, that is the drawing that you should do. We only draw the skeleton. We've left out all the hydrogens. All right, moving on. 3,3-dimethylhexane. 2, 4, 6. And then 3, 3. I'm going to be kind of funny and just start from the right-hand side for my numbering. And that is 3,3-dimethyl, and that should be differentiated from 3-ethyl. 2, 3, 4, 5, 6. And I'll switch things up. There's my ethyl. So the ethyl is a single 2-carbon attachment. The dimethyl is 2 1-carbon attachments. So the difference between the last two is there's both with total of 8 carbons, an octane isomer, and the carbons are just arranged differently, so they are structural isomers. Okay, 2, 3, 4 trimethylheptane. So 7, 4, 5, 6, 7. And then I'm going to be weird, number from the right, but I could do it from the left if I wanted. And on the second, the third, and the fourth, there is a trimethyl. So this will be about the extent of our lesson. I hope that is helpful for you, and we'll continue with a quiz next class day.